Good morning, grade 12 mathematics teachers. Good morning, colleagues. My name is Mohapi, subject advisor for mathematics in Mutao district. Today we are going to discuss the marking guidelines. Remember, grade 12 learners are sitting for a test today. It is their first formal test of the year. So we are going to discuss it so that we ensure that the marking goes smoothly in Free State. All grade 12 learners will be sitting for this test. We just want to ensure that teachers are familiar with the marking guidelines. The main purpose is to ensure that all learners in Free State are marked uniformly and consistently, so that each and every learner must get the marks that he or she deserves. Without any waste of time, let me dwell into the memorandum, the marking guideline discussions. At the moment, what is projected is the test. It's 100 marks. It's going to be written for 2 hours. 100 marks is going to be written for 2 hours. So it is important that learners, every time, let's encourage our learners to go through the instructions. Because the instructions are clear. There will be 5 questions, show calculations. The last one, number 4, a formula sheet is attached at the end of the question paper. Remember, this is a test, the first one. So at the end of the question paper, there is a formula sheet. Our grade 12 learners, it's for the first time that they come across a formula sheet. So please make them aware, and even when you revise, from time to time, take them through the formula sheet so that they should be able to use it. Because once they write down the formula wrongly, yet the formula is given in the formula sheet, that is a breakdown, meaning the learner will lose all those marks. So we have to be careful. This first formal test, formula sheet is attached. So let's go to the marking guideline discussions. Before I discuss the marking guideline, let's check the first question. This is a question paper. The first question reads, the following sequence is a combination of alternating terms of an arithmetic and a geometric sequence. 3, 3, 9, 6, 15, 12. Let's check the first question. Write down the next 2 terms for 2 marks. 1.1.2, give the general term of the arithmetic sequence. 1.1.3, write down the general term of the geometric sequence. Let me discuss those first 3. 1.1.1, 1.1.2, and 1.1.3. Let's check. This is the marking guideline. The marking guideline. As you can see, we've even highlighted in yellow the geometric series. If you can check the odd, the first, the third, the fifth, and so on, all the odd numbers is a arithmetic sequence. Geometric will be the even. Term number 2, term number 4, term number 6, and so on will then constitute a geometric. As a result, if you take the arithmetic, the common difference is 6. So it means you have arithmetic is 3, you add 6, got 9, plus 6, you've got 15, you add 6, you'll get 21. The question wants to write down the next 2 terms. So the first term will be 21. Look at the geometric series. 3 multiplied by 2, 6. Multiplied by 2 is 24. Multiplied by 2, 3 multiplied by 2 is 6. Multiplied by 2 is 12. 12 multiplied by 2 will then give you 24. So the next 2 terms are 21 and 24 respectively. Thank you. It's an accuracy mark. By accuracy mark, I mean these are the only correct answers. It's either this or nothing. It's an accuracy mark. Remember that 1.1.2 determine the nth term of the arithmetic. Look at the arithmetic. The first term will be 3. It's 3, 9, 15, 3, 9, 15, they form arithmetic sequence. The first term is 3, and the common difference is 6. So the first mark will go for the A, which is the first term. The second mark goes for D, which is the common difference. And the third mark goes to the nth term, which is minus 3 plus 6n. Thank you very much. Check 1.1.3. Determine the nth term of the geometric series. This is the geometric series. The value of A is 3, and the value of R, the common ratio, the constant ratio, is 2. So it becomes 3 multiplied by 2 exponent n minus 1 for 2 marks. 1 mark for A, 1 mark for R. That is the nth term of a geometric series. Let's check 1.1.4. 1.1.4, let me take you to the question. Determine the value of T22 minus T21. We have to be careful here. Term number 22, you subtract term number 21. Let's check. We have two types of sequence. It's arithmetic and geometric. So T22 refers to the 11th term of geometric series. Teachers, get this one clear. Term number 22 is basically the 11th term of geometric series. So the 11th term of a geometric series, 3 over 2 multiplied by 2 exponent 11 minus 1. And this gives us 3072. In the geometric series, this is the 11th term. But in that pattern, this is term 22. Check T11 of arithmetic, the 11th term of arithmetic. 11th term of arithmetic is basically term number 21 in the pattern. So T11 will be minus 3 plus 6. You substitute here n by 11. Then it gives you 63. Therefore, it means term number 22, if you subtract term number 21, term number 22 is basically the 11th term in a geometric. 3072 minus 63, and then the answer is 3009. First mark for T11 of geometric, second mark for T11 of arithmetic, the difference between the two, to say 3072 minus 63, then the answer, which is 3009 for 4 marks. That's how marks are distributed in that question. I hope it's clear. I've explained it slowly and clearly. I hope we will be able to mark it uniformly throughout the province. Fine. 1.1.5. It's a proof type of a question. It's a proof type of a question. Prove that all terms in this sequence will be divisible by 3. Prove that all terms in this sequence will be divisible by 3. Check. Check the nth term of arithmetic. Is minus, here is the nth term, minus 3 plus 6n. So if you divide it by 3, you've got minus 1 plus 2n. So all terms in the arithmetic are divisible by 3. Check the geometric. 3 multiplied by 2 exponent n minus 1. If you divide by 3, it gives you 2 exponent n minus 1. Therefore, it means even in the geometric sequence, all terms are divisible by 3. Both arithmetic and geometric, all the terms are divisible by 3. Therefore, this is the proof that is expected from learners. 1 mark for arithmetic, 1 mark for geometric is 2 marks. And this brings us to the end of question 1.1. Let's check question 1.2. Thank you. There is question 1.2. It reads, given the quadratic sequence 349, 310, 273, 238, 205, 174, and so on and on. The first question on the quadratic, determine the nth term of the pattern. Determine the nth term of the sequence. For 4 marks, determine which term or terms has a value of -2. Now we are going to discuss 1.2.1 and 1.2.2. 1.2.1. The first mark goes for the first difference. The first difference is -39, -37, -35, -33, -31. Those are the first difference. -39, -37. Even just the first three terms, -39, -37, -39. Those are the first difference. That is the first mark. The second mark, second difference, which is 2. The third mark goes to the value of A, which is 1, value of B, which is 2, and the value of C, which is 3. Then that constitutes the 5 marks in this question. 1.2.1. Let me rectify that one. 1.2.1 should be 4 marks. 1.2.1 should be 4 marks. Let me rectify that. Allow me to rectify that. We said the correct mark distribution, this one must be taken out of this one. Let me delete this one. It's out. So the first mark must be the second difference. The first mark must be for the second difference, the value of A, the second mark, the value of B, the third mark, the value of C, the fourth mark. And this question, all in all, it carries 4 marks. It carries 4 marks. Can I repeat 1.2.1 for 4 marks? Initially, the memorandum and the question paper were not aligned, but now I have rectified that. The first mark goes for the second difference, which is 2. Then you determine the value of A, which is 1. Value of B, -42, another mark. The value of C, which is 390, the fourth mark. Then the nth term is n squared minus 42n plus 390. That is how the 4 marks are distributed in this question. Question 1.2.1, 4 marks, not 5. 4 marks. Thank you very much. Check 1.2.2. Which term of the pattern will be equal to -2? So you equate this nth term, Tn here, from 1.2.1. You equate it to -2. Colleagues, remember, 1.2.2 will be a CA mark from 1.2.1. And remember the condition for the CA. You only CA on condition that you still have a quadratic pattern. If the learner ends up in 1.2.1 with a linear or any other pattern which is not quadratic, the learner will automatically forfeit the 3 marks in 1.2.2. So you only CA 1.2.2 on condition that 1.2.1 is a quadratic pattern. Thank you. Equating this to -2 is the first mark. And then write the equation to standard form, factorize. The value of n will be 28 or n will be 14. 1 mark for equating to -2, 1 mark for n is equal to 28, 1 mark for n is equal to 14. Both solutions holds. Remember, n in this case, it indicates, or the role of n is to denote the position of a term in the pattern. So it means n should always be a natural number. So 28 is a natural number, 14 is a natural number. So both values valid. If a learner rejects one value, then that learner will immediately forfeit that mark. Because in this case, both solutions hold. Both solutions will satisfy the equation. It's quadratic in nature, so it makes sense that we can have 2 terms with the same corresponding y value. It is perfect. If a learner, for one reason or the other, rejects one of the solutions, that learner will get 2 out of 3. The learner must accept both solutions. Thank you very much. That was 1.2.2, a question based on quadratic pattern. Let's check question 1.3. Let me go to the question paper. Given this, you are given that sigma, determine the value of P. See, this is equals to P, determine the value of P. Teachers must always, please, we preach it every time when you talk of a sigma. Sigma is nothing else but a summation. And for a learner to approach a question that involves sigma, the first step is to expand. The first step is to expand. You substitute n by 1, and then by 2, and then by 3. Then you are able to establish the type of a sequence here. If you cannot just tell by inspection that already this is a geometric pattern. Nonetheless, the easiest and most reliable method, expand the first 3 terms. Then you'll be able to see the type of a pattern and even be able to determine if it's a arithmetic, what will be the common difference, or if it's geometric, what will be the constant ratio. But P here, it represents sum. P here represents sum. So let me take you through to 1.3, marking guideline. 1.3, there is the expansion. You substitute n by 1, it will be 9 divided by 3, which is 3. You substitute n by 2. 3 squared will give you 9. It will be 9 divided by 9, which is 1. Substitute n by 3. It will be 3 exponent 3, which is 27. It's 9 over 27, same as 1 over 3, and so on and so on. Every time step number 1, expand. Now that we have expanded, you are able, that will be the first mark. Expansion is the first mark. Now to determine the value of R, this is a geometric series. It's a convergent geometric series because R is equals to 1 over 3. It can be T3 over T2 or T1 over T2, whatever way. R here will be 1 over 3. That will be the second mark. And the third mark will then be the final answer. Remember, sum to infinity, we have this formula. It is there in the formula sheet. Already, the value of A is 3. The value of R is 1 over 3. So it will be 1 minus 1 over 3. 1 minus 1 over 3 will give you 2 over 3. Therefore, 3 divided by 2 over 3 will leave you with 9 over 2 as the value of P. How are marks distributed? 3 marks. Mark distribution, I repeat. 1 mark for the expansion, 1 mark for the value of R, 1 mark for the answer. Thank you very much. And this brings us to the end of question 1. This brings us to the end of marking guideline discussion for question 1. Thank you. Now I'll have to cross over to question 2. Let me take you through the question paper. Remember, question 1 was 23 marks, done. We have discussed it. It was the 23 marks were based on patterns, sequences, and series. Patterns, sequences, and series. Those were the first. That was the first question, and it carried 23 marks. Fine. Let's have a look at question 2. Question 2 is a question based on Euclidean geometry. This is the topic where learners must provide reasons for their statements. Question 2 reads, 2.1. In the diagram, ABCD is a cyclic quad. ABCD is a cyclic quad. It's a cyclic quadrilateral. Chords AC and BD intersect at F. They intersect here at F. BD and AC, they intersect at F. AD produce BC, produce at G. EB is a tangent to the circle. Here is EB. EB is a tangent to the circle. AC produce cast the tangent EB at E. Here it is. AC, it's AC produced. You produce it to E, where it intersects the tangents EB. Thank you. AF is equals to BF marked. AF is equals to BF, and immediately learners come across this. Let's teach our learners. Immediately they must be able to interpret. Once they are given that AF is equals to BF, then you know angle A2 must be equals to angle B3. But those are the angles opposite equal sides. Once you are given that A, B, C, D is a cyclic quad, then you can apply all the theorems related to cyclic quad. exterior angle equals to the interior opposite angles, sum of opposite angles supplementary, angles in the same segment of circle are equal. Those are the theorems that we should immediately know once we come across the word side quad. The first question, express, given reasons, the success of the following in terms of x and y. A1, A2, C2, and C4. These are the 4 questions that we are going to discuss. We express them in terms of x and y. A1, A2, C2, and C4. Let's check the marking guideline discussion, the memorandum. A1, here is A1, it is equals to B2. Those are the angles in the same segment, or angles subtended by arc CD. Angles subtended by arc or chord CD. Those are the angles in the same segment. 1 mark for a statement, 1 mark for a reason. If Elena only writes down the correct statement, that Elena will get 1 out of 2. For Elena to get full marks, there must be a reason and a statement. We are not being harsh. We have to be fair in marking this letter, because the way we mark them now, that's how these learners will now behave moving forward. If we penalize them now, they will realize, hey man, we lose marks. Come the exam, come trial, end of the year later, they must be able to answer the questions correctly. So if a learner only write down the statement, and you as a teacher, you allocate 2 marks for that learner, you are misleading the learner, because come the end of the year, the learner will be penalized. We must teach them the correct way of answering questions. This is Euclidean geometry. Learners must be able to provide reasons for their statement. So according to this marking guideline, 1 mark must go for the statement, and 1 mark must go for the reason. Check 2.1.2, A2. Look at A2. A2 here is A2. You look at A2, you look at B2. We say A2 is equals to B1. Remember, EB is a tangent, né? EB is a tangent. So A2 is equals to B1, which is equals to X. The reason, tan chord theorem. Angle between a tangent and chord is equals to angle in the alternate segment. But you can also accept Elena if the reason, tan chord theorem. Thank you. So still 1 mark for a statement, 1 mark for the reason. Let's check 2.1.3. B3. Here is B3. Remember, A2 is equals to B3 is equals. We have already calculated A2. We have already expressed A2 in terms of X. We said A2 is equals to X. Now A2 is equals to B3 is equals to X. So even B3 is also X, because these are the angles opposite equal angles. Now we go to B3 is equals to C2. Here is C2 now, because we need to express C2 in terms of X or Y. So in this case, it becomes easy for us to express it in terms of X. So C2 will be equals to X. They are both on AD, or the angles subtended by chord AD, angles subtended by arc AD, or angles in the same segment, or AD subtends equal angles, whatever reason. Please accept. Every time, 1 mark for a statement, 1 mark for a reason, as indicated in the marking guideline. It's important for us as teachers to make sure that we adhere to the marking guideline. 2.1.4, C3. Check angle C3. Here is angle C3, this one. C3, this one. There is C3. You add it to angle A2. You add it to angle B3 and Y2. They give you 180 degrees. Those are the sum of angles in a triangle. Those are the sum of angles in a triangle. So if you make C3 the subject of the formula, C3 will then be equal to 180 degrees minus 2x plus y. I've explained it clearly. And 1 mark for a statement, another one for a reason. What is the statement? Statement is C3 equals to 180 degrees minus into 2x plus y, where C3 is made the subject of the formula. That is our statement. If the C3 has been made the subject of the formula correctly, the statement, 1 mark for the reason. Now the question wants us to express C4 in terms of x and y. If C3 is 180 degrees minus into 2x plus y, now C3 plus C4, C3 plus C4, they will give you 180 degrees because those are the angles on a straight line. Therefore, you make C4 the subject of the formula. C4 will be equal to 180 degrees minus C3, which is 180 degrees minus, in brackets, 2x plus y. Then you simplify, C4 will be equal to 2x plus y. 1 mark for a statement, 1 mark for the reason. Let's adhere to the marking guideline, the way the marking guideline distributes marks. That's how marking should be done. So this will then bring us to the end of question 2.1.4. Let's go to 2.2. Let me take you through the question first. 2.2. Thank you. 2.2. Here is question. It reads, I'll be slowly and we must understand. In the diagram, BD is the diameter of the circle with center M. That is BD, M is the center. So it means BMD is a straight line, it's a diameter. It is a straight line. Angle AMC is equal to 128. Here is that AMC at the center, because M is the center. And angle D1 is equal to 32 degrees. This is D2, this is D1, this is D1. Even 32 degrees here is given, it should be D1. Should be D1, which is equal to 32 degrees. Now let's answer the following question. Calculate, taking reasons, the numerical values of angle D2 and angle C1, 2 marks each. Let me take you through to 2.2.1 and 2.2.2. 2.2.1 and 2.2.2. This is the marking guideline discussion. 2.2.1 D2, remember, 128 degrees is equal to twice angle D. So angle at the center, twice angle at the circumference of the circle. Therefore, it means the whole of angle D is 64. The whole of angle D is equal to 64. And angle D is divided into two, into D1 and D2. Angle D is divided into angle D1 and angle D2. And together, both angles give you 64. So if D1 is 32, then D2 will also be equal to 32. So that when you sum them up, they give you 64. Statement, reason. What is the size of angle D2? 32 degrees, the statement. What is the theorem applied? Angle at center is equal to twice angle at the circumference of the circle. Clear about the first 2 marks. The next question then wants us to calculate C1. Here is C1. C1 is equal to D2. Remember, angle D2 is 32. We have calculated D2 to be 32. So C1 is equal to D2, which is equal to 32 degrees. The reason, they are subtended by arc AB. They are both on arc AB. AB subtends equal angles at the circumference of the circle. Or you can say angles in the same segment. If the learner says angles in the same segment, you still give 2 marks. 1 mark for the statement, 1 mark for the reason. I want you to listen attentively. That's it. That's 2.2.1 and 2.2.2. Let's go to 2.2.3. Maybe I should take you through this addendum. Let me teach us through this addendum. Question 2.2.3. Prove that ABCD circular quadrant is taken out. That question has been taken out. It's out. We must understand. We no longer have 2.2.3. It's out. And it has been replaced by this one. It has been replaced by this question. Let me make it smaller. Allow me to make it smaller so that, thank you, there it is. And this will be 2.3. 2.2.3, it's out. It was 6 marks, it's out. It's been replaced by this one, 6 marks. So before I can come to this one, let me finish off question 2.2.3. You see, this 2.2.3, the first 2.2.3, this one is out. This one is out. The only question that is left is calculate angle B. This 6 marks is out. This one, it is out. The reason being, already in answering 2.2.1 and 2.2, it was already implied that A, B, C, D is a cyclic quad. So it doesn't carry weight anymore, because already to answer the first 2 questions, it was already implied. And even again, when you look at the diagram, it's quite clear that both those 4 points lie on the circumference of the circle. We know that sometimes it's always the case that diagrams are not drawn to scale, but the manner in which question 2.2.1 and 2.2.2 were answered, it was already implied that A, B, C, D is a cyclic quad. Hence, the question has been taken out and replaced by the proof of that theorem. Clear. Now we go to question 2.2.3, basically is B. Calculate angle B. Where is this angle B? Here is angle B now. This is the angle that you should calculate. And this is how the marking guideline goes. Angle B is equal to, check angle B, this angle B plus angle whole of angle C plus D2. They should give you, plus D1, they should give you 180 degrees. Those are the sum of angles in a triangle. So angle B will be equal to 180 degrees minus 90. That angle C, which is 90, minus 32, which was given. Therefore, angle B is equal to 58 degrees. The resident sum of angles in a triangle. Therefore, 2 marks for statement, 1 mark for a statement, 1 mark for the reason. The whole question is 2 marks. Thank you. Done. Now we go to 2.3. What does question 2.3? Remember, 2.3 is the one that has been replaced, the one that is replacing the initial question. And it reads, here is the question, as it appears on the addendum. It reads, in the diagram, triangle ABC is drawn. D is a point on AB and E is a point on AC such that DE is parallel to BC. BE and DC are drawn. Prove the theorem that, use the diagram to prove the theorem which states that the line drawn parallel to one side of a triangle divides the other 2 sides proportionally. In other words, prove that AD over DB is equal to AE over AC. We want to prove that. Now, let's check the proof. Let's check the proof. The first mark goes for the construction. First mark goes for the construction. What is your construction? You draw H1 for E perpendicular to AD and H2 for D perpendicular to AE. There must be that construction there. There will be that construction there. And the learners can denote not necessarily H1 and D, whatever, but those are H1 and H2 represent heights. But whatever notation that learner use, you must accept. Some will say H, the other one can be T or whatever, P, any, it's fine. As long as it's a line from E perpendicular to, from AD, from E perpendicular to AD, and again from D perpendicular to AE. That is the construction mark. Another part of the construction, remember, you join BE and DC. You join that. First mark, 6 marks. First mark goes for construction. Now you work at area of triangle ADE over area of triangle BDE. Half base by height. Base becomes AD for triangle ADE, and base becomes DB for triangle BDE. H1, common height, half and half, they cancel off, then you're left with AD over DB. That will be the second mark. The third mark, area of triangle ADE divided by area of triangle DEC, where AE is the base for triangle ADE and EC is the base for triangle DEC. H2, the common height, they cancel off, half and half cancel off, therefore you are left with AE over EC. That is the third mark. That is the third mark. Most importantly, the fourth mark. Area of triangle BDE is equal to area of triangle DE, because those two triangles, they are within parallel lines. So if they are within the parallel lines, they've got the same height. And they can share the same base. Statement and a reason. Based on that, you equate these two. AE, triangle ADE over BDE is equal to area of triangle ADE over DEC. Remember, here I've got a mark for statement and a reason. What is this mark, statement and reason? Area of triangle BDE equals to area of triangle DEC. It's a statement mark. Reason, same base, same height. So the sixth mark is for drawing a conclusion that area of triangle ADE divided by area of triangle BDE is equals to area of triangle ADE over area of triangle DEC. That is the sixth mark. Then, and this brings to the total to question 2 to 24. Question 2, 24 marks. And this question 2 was on Euclidean geometry. Question 1, we did question 1, and question 1 was based on patterns, sequences, and series, 23 marks. Now we are done with question 2, 24 marks, which was based on Euclidean geometry. I explained the issue of the addendum correctly. Thank you very much. Now, question 3. Let's go to the question paper. Question 3. Still Euclidean geometry. The statement reads, in the diagram, triangle ABC is such that F is on AB. Here is F. It is on AB. Here is F. And G is on AC. Here is G. It's on AC. And CB is produced to meet GF at E. To meet GF at E. Here it is point E. DGF is a straight line. DGFE is a straight line. BFA is parallel to CD. What is BFA? BFA, this line parallel to this one as marked in the diagram. AB is 20. Colleagues must always teach or encourage their learners to indicate the given information on the diagram. That is a very critical skill, because once the information that is given has been clearly indicated on the diagram, it becomes easier for a learner to work out the problem. Like, if AB is 20, look at AB. AB, the whole of AB is 20. BC is 10. Here is BC. You write 10 here. BC is 10. EF is 8. Here is EF is 8. EB is 5. Here is EB is 5. And FB is 6. Here is FB. If FB is 6, it means AF will be 14. Because remember, the whole of AB is 20. So if FB is 6, it means AF will be 14. So we must, from time to time, and be patient with our learners, teach them how to indicate the given information on the diagram. Now it becomes easy for us to answer the question. The first question then reads, let me take the first two questions. Determine the numerical value of EF over ED. Check EF. EF over ED. We want to determine the numerical value of that. Taking into consideration BF is parallel to CD. So we apply the proportionality theorem. A line parallel to a side of a triangle will divide the other two sides in the same proportion. The 3.2, calculate the length of ED. Calculate the length of ED. Because we have now determined the ratio, now it's easy for us to work out the length of ED. Thank you. Let's check the marking guideline for question 3. EF over ED. Check it. EF over ED, it will be equals to EB over EC. EB over EC, which is equals to 5 over 15. Statement reason. Why? Line parallel to a side of a triangle. Sometimes some learners may write as proportionality theorem, others may FB parallel to CD, others will write a reason, a line parallel to a side of a triangle. Whatever reason that I've mentioned, you credit that learner. 1 mark for the statement, 1 mark for the reason. So EF over ED is 5 over 15. I hope you have corrected that. 3.2. The question wanted us to calculate the length of ED. ED. We have now worked out the ratio EF over ED, and that ratio is 5 over 15. Now it will be easy for us to work out the length of ED. EF over FD. What is EF? EF over FD. EF over FD will be the same as EB over BC. Working it out, you'll have 5 over 10, which is basically 8 over FD is equals to half. Then FD will be 16. Now, FD will then be 16. The question wants you to calculate ED. So, if this EF is 8, FD is 16. You add the 2, you've got ED as 24. 1 mark for substitution. FD is equal to 16. Then the answer, which is D, is equal to 24. 3 marks. Bringing us to the end of 3.2. Let's check 3.3 and 3.4. Let me take you through the question paper. 3.3, complete without stating reasons. Triangle EFB is similar to triangle, we'll just complete. And then ultimately calculate the length of DC. Hence, calculate the length of DC. The word hence means use the information obtained earlier to calculate DC. Let's go to 3.4, marking guideline, 3.3 and 3.4. Similar triangle EDC. EDC, triangle EDC. Remember, we're just completing. Triangle EFB is similar to what? To triangle ECD. EDC. Done. Now that we have completed that, we need to calculate the length of CD. We need to calculate the length of CD. Here is CD. Calculate the length of CD from similarity. 6 over CD will be 8 over 24. And then if you work out the length of CD there, it will be 18. The length of CD will then be 18. 1 mark for substitution, 1 mark for answer. 3.5. Take you through the question for 3.5. 3.5. Prove that AF over CD. AF over CD. You look at AF. AF over CD is equal. See, here is CD. Is equals to FG over DG. FG over GD. Thank you. Let's see. Let's start. That was the question for 3.5. Check the marking guideline discussion. The marking guideline. In triangle AFG and CDG, here are the two triangles. In triangle AFG, this triangle, and DCG, we compare this triangle and this triangle. Already angle A is equal to D1. The two lines are parallel. CD is parallel to FB. So these are the alternating angles. Same reason goes for F3 being equals to angle D. And G1 is equal to angle G3. Those are the alternating angles. So you have already the three angles that are equal. The two triangles are equiangular. As a result, they become similar. 3.5, like I said, angle A is equal to C1. Those are the alternating angles, where CD is parallel to AB. G3 is equal to G1. Those are the vertically opposite angles. Then we've got two pairs of angles equal. In two triangles, two pairs of angles are equal. It goes without saying that even the remaining pair will also be equal. So meaning triangle AFG, similar triangle CDG, angle, angle, angle. then the conclusion. This brings us to the end of question 3.5, which is 13 marks. We have come to the end of question 3, which is 13 marks. For now, colleagues, I'm going to ask for 5 minutes break so that I can have a cup of water. After getting a cup, after 5 minutes, we'll then resume with question 4 and 5. For now, we need to go for a break. Thank you very much. Let's resume after 5 minutes. Colleagues, let me welcome you back after a very short break. Now we have to resume with question 4 and 5 of the grade 12 test. Going to discuss the marking guideline thereof. Without any waste of time, let's go to question 4. 4.1. Use the figure below to answer the following questions. Here is the diagram, the x-axis and the y-axis and theta in the standard position. Determine the length of OP for 2 marks. Determine the value of cos 2 theta for 3 marks. 4.1.3, evaluate 17 sin squared theta plus 5 over 2 tan theta for 4 marks. 4.1.1, 4.1.2, 4.1.3. Let's check the marking guideline, the marking guideline, how the marks will be distributed. 4.1 is Pythagoras Theorem. Remember, in the diagram you were given -3 and 5. So according to Pythagoras Theorem, OP squared is equal to 5 squared plus -3 squared. Therefore, OP is equal to square root of 34. 1 mark for substitution, 1 mark for the answer, which is square root of 34. 4.1.2. We need to determine the value of cos 2 theta. It's a compound angle identity for cos. And remember, we've got 3 ways of expanding that. So the one we used here in the marking guideline is cos squared theta minus sin squared theta. And cos is -3 over the square root of 34 all squared, minus sin will be 5 over square root of 34 all squared. If you remove the brackets, you will end up with 9 over 34 minus 25 over 34, which is -16 over 34. So how are marks distributed? The first mark for expansion, cos 2 theta. It's either we use this one or any other two. 2 cos squared minus 1 or 1 minus 2 sin squared theta. They will all give you the same answer. So whatever expansion, one of the 3 is either cos squared minus sin squared, or 1 minus 2 sin squared, or 2 cos squared theta minus 1. Any of the 2 is a mark, and a substitution thereof is a mark, and then the final answer, which is -16 over 34. That's 3 marks. 4.1.3. We need to evaluate 15 sin squared theta plus 5 over 2, the tangent of theta. So you write 17 here. Instead of sin theta, you write 5 over square root of 34. Because it's sin squared, you square this one. Plus 5 over 2, tangent of theta is 5 over -3. 1 mark for substituting sin squared, sin. 1 mark for substituting tangent. It's for 4 marks. 1 mark for substituting sin, 1 mark for substituting cos. Simplification here refers to removal of brackets and multiplication thereof. Let's check. If you remove brackets and multiply by 17 here, you've got 25 over 2. This one will give you 25 over 6. So the answer is 25 over 3. 4 marks. 1 mark for substitution of sin, 1 mark for substitution of tangent. Simplification, meaning removal of brackets. You square and then you multiply by 17. And you also remove the brackets in 5 over 2 into 5 over -3. Then the final answer, 25 over 3. 4 marks. 4.2. 4.2, let's go to the question paper for 4.2. Sorry, 4.2. I will discuss 4.2 and 4.3. Simplify without a calculator by showing all necessary steps. We simplify this expression. The sine of 190, the cos of 205 degrees, the tangent of 390 degrees, all over the cos of 100 degrees divided by the sine of 115 degrees for 8 marks. Let's check the mark distribution. Instead of the cos of 190, you write 180 plus 10. That breaking it down into 10. 1 mark. Break that obtuse into an acute. 180 plus acute. 180 plus 10 is a mark. check 205, you break it down to 180 plus 25, the second mark. It was 390, now it becomes 360 plus 30 is the third mark. Cos of 100 is 90 plus 10, the fourth mark. Now, the fifth mark, we've got the sine of 115 will be the sine of 90 plus 25, fifth mark. Now we reduce all those to acute. Minus sin 10, a mark. Minus the cos of 25, a mark. This one is tan 30. The mark is for minus cos 25 and minus 10. Minus the sine of 10, minus the cos of 25. 1 mark each. Then this one must be tan 30 minus sin 10. Even if any of this can be correct, as long as these first two are correct, then I will get those 2 marks. Then I will end up with 7 out of 8. In case any of the others have been, in case of any of these 3 ratios has been reduced incorrectly. As long as the first one minus the sine of 10 degrees, the second one minus the cos of 25 are correct, mark a mark. After simplification, the tangent of, you are only left with minus the tan of 30 degrees, which is equal to negative 1 over 3. That is the 8th mark. And this brings us to the end of question 4.2. 4.3, remember we have to prove that sine 2 theta over 1 plus cos theta is equal to tan theta. We have to prove that this expression here is equal to the tangent of theta. Let me show you in the question paper. There it is. Prove that the sine of 2 alpha divided by 1 plus cos 2 alpha is equal to the tangent of alpha for 4 marks. Let's check the mark distribution in the marking guideline. This is a double angle identity for sine. So it's 2 sine alpha cos alpha, the first mark. Cos 2 alpha is a double angle identity for cos. Then here we express it as 2 cos squared alpha minus 1, second mark. Now you subtract. 1 minus 1 will give you 0. You have denominator as 2 cos squared alpha. The third mark. This one, 2 cos squared alpha. Denominator simplified. It's simplified as 2 cos squared alpha. 2 cos squared alpha because 1 minus 1 will give you 0. The third mark. Now you simplify and you cancel. You're left with sine alpha over cos alpha. That will be the fourth mark. The fourth mark will be sine alpha over cos alpha. Teachers must be careful, especially if they mark this proof type of questions. Because once they see the final answer is tan alpha, you just normally give a linear mark. No, that is not how to mark. Check the steps leading to that. Check the steps leading to that conclusion. When you mark a proof type of a question, you don't look at the final answer because obviously it was already given in the question. So you need to check thoroughly the steps leading to that conclusion. Hence, even if you check the mark distribution here, it's perfect. All the marks are allocated to the steps leading to the conclusion. 4 marks. And this will then bring us to the end of question 4, which is 21 marks. Let's go over to the last question. Question 5. Let me go to the question paper. Question 5. Here is question 5. Thank you. Question 5, colleagues. Here it is. 5.1. If the sine of 32 degrees equals to t, express the following in terms of t. Got 4 questions. We must express them in terms of t. Sine 32 degrees equals to t. Express each of the following in terms of t. Immediately, we must expose ourselves to this type of questions. Because the first thing that they need to do is just to draw a right angle triangle. And then work it out from there. So sine of 212, the cos of 58, the sine of 16, sine of 238 minus the sine of 160. Let's check the distribution of marks in the marking guideline. Remember, the sine of 212, before that you have the sine of 32 degrees equals to t. When you draw a right angle triangle, the side opposite to 32 degrees will be t. and then the hypotenuse will then be 1, because if sine 32 equals to t, it's t over 1. The denominator is 1. So it's t over 1. Now you use Pythagoras Theorem to determine the length of the remaining side, which is the square root of 1 minus t squared. The square root of 1, this is the mark. The square root of 1 minus, as you can see, it's the square root of 1 minus t squared. The square root of 1 minus t squared. Just that here it appears as, but it should be, first mark should be the square root of 1 minus t squared. Now, the sine of 212, you expand it and then reduce it to acute. Minus the sine of 32 degrees is a mark, and then the answer, which is negative t, a mark. 3 marks. Cos 58. Reduce 58 to 32. Then it becomes 90 minus 32. It's a mark. And the cos of 90 minus 32 becomes the sine of 32. And it's giving the sine of 32 is equal to t. Second mark. Some learners can just read it from the diagram to say, if this angle is 32 here, that one there should be 58. So the cos of 58, cos is adjacent over hypotenuse. Here, this angle up here is 58. So cos thereof is adjacent over hypotenuse. Hence, even the examiner said for answer only, give full marks. Because already, if you have 32 here, automatically that angle becomes 58. So you don't have to convert to psi. You just say cos 58. If you have 58, is adjacent over hypotenuse. Answer only, full marks. 2 marks. 5.1.2 answered. 5.1.3. Remember, 5.1.3, you've got the sine of 16. Sine of 16, let's check. We are from the diagram, you have 32 degrees. So 16 is half of 32. Learners must be able to see such things because they studied double angles. So the moment you see 32, then you must see, the moment you see 16, and you try to link it to our diagram, you must be able to tell that 16 is half of 32. So you think along the lines of the double angle identity. So the cos of 32 degrees equals to 1 minus 2 sine squared 16. This is the identity. So you've got the cos of 32, cos 32, square root of 1 minus, the square root of 1 minus t squared, minus 1, which equals to minus 2 sine squared 16. The first mark is the expansion. Application of the compound angle identity. Not anyone, double angle identity. That is the first mark. The second mark is the substitution. What do we mean by substitution? The cos of 32 is square root of 1 minus t squared. That is the second mark. Now you make sine squared 16 the subject of the formula. You end up with this. You end up with 1 minus the square root of 1 minus t squared all over 2. Now you determine the square root thereof because the question expects a learner to work out the sine of 16, not sine squared 16 degrees. Therefore, the sine of 16, determine the square root both sides, will be the square root of 1 minus the square root of 1 minus t squared all over 2. Final answer. 1 mark for expansion, second mark for substitution, sine squared as sine squared 16 degrees as a subject of the formula, this step here, and then the final answer, which is sine 16 degrees is equal to the square root of 1 minus the square root of 1 minus t squared all over 2. 5.1.3 answered correctly so for that matter. Last question, 5.1.4. The sine of 238 degrees minus the sine of 116. A bit challenging because now you try to link it to the diagram. But if you link it to a diagram, like I said earlier, it's important as we teach these learners this type of problems, they must write down the sizes of all angles. If they draw a right angle triangle, here it is drawn. This angle is 90, this one is 32. Then it means that one must be 58 degrees. The one on top there should then be 58 degrees. That will help you a lot in answering this question, because 238 is the same as 180 plus 58, which is minus the sine of 58. Sine of 116 is double angle identity for 58. Sine of 258, then this is the expansion thereof. Check the mark distribution. To express 238 in terms of 58, a mark. To express the 116 in terms of 58, it's a mark. Here they are. The first mark, sine of 2 multiplied by 58. That is the second mark. The first mark was 4, the sine of 180 plus 58. Now, if you reduce this, it becomes this one, this step. Thank you. Now we substitute. What is the sine of 58? Minus the sine of 58. We minus the square root of 1 minus t squared. That is the first mark. You check here. Substitution is 2 marks. Substitution is 2 marks. The first substitution, the sine of 58, square root of 1 minus t squared, a mark. 2, the cos of 58, multiply by the sine of t, which is t, and then you take out a common factor. Common factor will be 2t minus 1 into the square root of 1 minus t squared. Sine 58. I need to clarify this one here. Maybe it does not appear well. The sine of 58. Go to the diagram. Here is 58. The sine of 58 will be opposite over hypotenuse. The square root of 1 minus t squared over 1. Perfect. Here it is. Here it is. 2, you see this one. This is still the sine of this one. The sine of 58 still gives you this one. But this t is for the cos of 58. Substitution is 2 marks. 1 mark for the square root of 1 minus t squared, 1 mark for t. And then simplify that one, taking out square root of 1 minus t squared as a common factor. You have 2t minus 1 in brackets and the square root of 1 minus t squared. This is the final answer. 5 marks, perfect. Thank you. The last question, 5.2. Determine the general solution of 2 cos squared theta plus cos theta minus 1 is equal to 0. Let me take you through the question paper. So that it should be here. Determine the general solution of 2 cos squared theta plus cos theta minus 1 is equal to 0. This is the question. We determine the general solution thereof. And this question is for 5 marks. Determine the general solution. This is the question. Determine the general solution of 2 cos squared theta plus cos theta minus 1 is equal to 0. 5 marks. Let's check the mark distribution. Because the equation was already written in the standard form. Now, factorize. 2 cos theta minus 1, cos theta plus 1. Therefore, cos theta is equal to half, the first mark. Cos theta is equal to half, the first mark. The second mark, cos theta is equal to negative 1. Now, let me explain that clearly. This step as a whole, this one, the whole of this one is 1 mark. The first mark goes for cos theta is equal to half or cos theta is equal to negative 1. Both a mark. If the learner only writes 1, then the learner will forfeit that mark. It must be both cos theta is equal to half or cos theta is equal to negative 1 mark. Reference angle. In this case, the reference angle will be 60. In this case, the reference angle will be 180. Both reference angles, a mark. The whole question was for 5 marks. Now that will be the second mark for reference angle. Plus or minus 60, the third mark. Plus or minus 180, the fourth mark. In both cases, the general solution multiply plus k 360, where k is an element of integers. That's how the 5 marks are distributed. Let me repeat that one. Cos theta is equal to half and cos theta is equal to negative 1 mark. Reference angle, which is 60 and 180, the second mark. Now you write down the general solution. Plus or minus 60 Here it is, a mark, plus or minus 180, a mark, and the learner must be able to indicate that it's a general solution by writing plus k, 360k, an element of integers. That will be the 5th mark. And this will then bring us to the end of question 5, which was 19 marks. And you add all the questions together, they'll give you 100 marks. This will then bring us to the end of the marking guideline discussion. Colleagues, teachers, you have seen how we went through the marking guideline. Please do your best and adhere to the marking guideline. If learners come up with the alternative solutions, check how marks were distributed in this column here, this last column, this column. It's a guideline. It guides you on how marks are distributed, so that if a learner can come up with an alternative solution, but this will guide you. Stick to that. And I believe, even us as teachers, we are also learning in the process to say, if this is how marks are allocated, we must go and teach our learners the correct mathematics. We always encourage teachers to teach learners concepts first. Once learners have understood the concepts and you evaluate them regularly, once learners have grasped the concepts, then we can then go to the previous papers and take questions and start discussing. But we start from the basic, easier ones, and then we up the level gradually. On that note, I hope our learners shall have written well, and I hope that they will get good results this year, and we're hoping for an improved learner performance at the end of the year. Colleagues, thank you very much for today. I thank you.